Good morning, good afternoon, and good evening, everyone. My name is Neeraj Keria. Now, today, as a part of our focus module, today we'll be focusing on what exactly Ansible is, right? So today, our main motive of this entire session would be having a good understanding of what is Ansible and what are the changes, what was the situation had been before and after configuration management, what exactly is Ansible, what are the features of Ansible. We'll be focusing on the case studies for Ansible, focusing on NASA, what their problem was and how the problem was solved using Ansible, right? And then we'll see how we can use Ansible for orchestration, how we can use Ansible for provisioning, for configuration management, for application deployment, and security, right? So like earlier, we had seen the usage of Puppet as well. Earlier, we had seen the usage of Kubernetes as a part of orchestration tool as well, right? And here we'll be focusing on how we can use Ansible for orchestration, provisioning, configuration management, application deployment, security, and different scenarios, right? And at last here, we'll be focusing on how to write Ansible playbooks to install the LAMP stack and host a website. That will be that'll be part of a small hands-on that we'll be focusing on towards the end of the session here. All right. So now let's get started on our discussion on the topic of Ansible. All right. So we had discussed the concept of configuration management. Configuration management basically establishes and maintains consistency of product performance by simply making sure that all the physical attributes of its requirements are already met, and that too centralized and that too automated through our entire system, right? Let us have a quick recap of what exactly is a configuration management system out there so that we can all be on the same page, right? So let's do that. For doing that, let's go to our Picasso mode here to have a quick recap of what exactly we mean by configuration management. For example, traditionally, if we want to deploy, suppose a single person wants to deploy a single server here, right? Suppose we need to deploy one server where we need to have, suppose, say, one version of PHP installed, right? And we need to have one version of MySQL to be installed and configured there. Suppose if we have a different version of PHP and MySQL to be installed and set up, suppose say here we are focusing on PHP 5.7, and again here we have suppose in MySQL again we are focusing on 5.0 as a part of the version that we need to configure on this server. Now, if we want to do this configuration here manually, we can do that. That wouldn't be any problem. It wouldn't be any challenge. And we can do the same thing for 2 servers, 3 servers, 10 servers. We can do that. That is quite manageable, right? But if we have hundreds of these servers, suppose if we have hundreds of these servers that we need to configure the same configuration, right? Then obviously we don't do that manually, right? So and for that purpose, we can use a simple configuration management tool where we can define one particular template. Now, just like we have a template here, so here we can define one template which will have the configuration for each and every system or each and every configuration that we need to perform or that we need on these servers here, right? So that when we are actually implementing this, the same configuration can be fetched from the file. So whatever has been mentioned here, the configuration for the same servers can be done in that manner, right? For example, suppose here we define PHP should be for this version, MySQL should be for this version, then the same thing will be used in order to configure those hundreds or those thousand servers, right? So again, and that too, instead of doing this manually, suppose let's say once it is done with configuring first server, then only moves to second. Once it's done with second, then only moves to third and so on. So instead of doing this in one by one, we can now this can take care of the configuration parallelly, right? So that different servers here can be configured parallelly without waiting for the first service to be completed. And that's why if manually we require, let's suppose 10 days, 15 days in order to configure 1,000 servers, then using this configuration management tool, we can achieve that within an hour itself, right? That's how efficient and that's how quick it is, especially when we have a big scale requirement. All right. Configuration management is basically used for making sure that the entire configuration is done exactly as per the requirements, right? So suppose if we have multiple applications or multiple configurations that needs to be replicated on each and every server, then we can use the configuration management to save us a good amount of time and our resources. Now, why exactly we need configuration management? Because before configuration management, there was problem in managing multiple servers together, right? and they have different configurations. Like we can say bigger numbers. Suppose let's say we want to deploy 50 servers, 500 servers, 1,000 servers. Again, that configuring each and every server was again not feasible by any manual methods, right? And that's why here we have application. That's why after the introduction of configuration management, then we can simply make sure that the entire application is deployed. And in servers, we can maintain multiple applications one by one. So one can be here focused only on web servers, one can be focused on database servers, one can be focused on application servers, right? So for each and every component of the entire application, be it the servers, be it the web server, be it the database servers, and be the application server, these all can be resumed and these all can be solved easily by the concept of configuration management systems out here. And then it also helps us in scaling up and scaling down our resources exactly as per our requirements. So suppose if we want to add more number of servers, and that too with the same configuration. For example, we had discussed the concept of scaling, right? We have horizontal scaling, and then we had discussed we have vertical scaling, right? Suppose in horizontal scaling, again, we want to add more number of servers. So currently we have 2 servers already been deployed here. And then we had seen the concept of vertical scale of horizontal scaling. Suppose now we want to add more number of servers, then obviously we have to, again here we can use the configuration management so that the same configuration servers, obviously we don't want a misconfigured server here. We want the configuration, if we are scaling horizontally, we want the same number of servers being deployed here, right? Same number and same type. And again, this entire problem was also solved using the concept of configuration management. That means here we can deploy, here we can scale up and scale down the resources exactly to what has been already deployed, right? So there's no mismatch and there's no basically mismatch between the configurations, right? That's the main advantage of using configuration management tool. And before the actual introduction to configuration management systems out here, now before we had the requirement of coding and deployment at the same time, right? And then deployment could have been done on the testing and production environments, right? Because again, let's say here we are working on any operations team here. Now, since we require a time, so suppose if we want to deploy this on testing server and we also want to deploy this on production server, right? Now, since there is no automation tool here, so obviously we will require time in order to set up the testing and in order to set up the production server, right? Suppose now the coders, they have shared the code to the repository here, and now using the CI server, that is Jenkins, we have now integrated now that has been integrated, right? But now suppose let's say because of the manual setup of the test server, suppose this is taking 15 minutes to be configured, and while this is taking suppose it says 8 minutes to be configured here, right? So obviously they are taking time. And suppose if we combine this 15 plus 8, that is 23 minutes, right? And suppose if we combine this 23 into, suppose if we are running 100 servers out here, then that exactly means 2,300 minutes we are wasting. We are wasting on the entire setup here, right? Now, suppose a developer wants to know the feedback of its code here, right? And then the developer needs to wait at least for 15 to 16 hours, right? So that then only it can start getting the feedback from the real-time implementation. And as we know, in DevOps, we have to be fast, we have to be quick, because again, if we are slow in our pace of implementing products, obviously we'll be having a trouble in wasting a lot of time. We'll be having trouble in saving time, right? So obviously we will be wasting a lot of time in these case scenarios, right? Whereas when configuration management, now each and every server can be configured in few minutes. Now, earlier it would have taken hours, but here it can be done in few minutes to few seconds, right? That's how fast the entire system has become. And that's why if we have a fast system, obviously we are going to get more number of active users as compared to other platforms. And that's exactly what we use configuration management system for. All right, so now let's erase this up. And the main challenge faced earlier was also to roll back to any of the previous state, or we can say to roll back to any of the previous state here. Now, when we say roll back, we simply mean, for example, again, we have to understand this in simple terms. Suppose again, there's the same scenario here. Suppose now we want to upgrade. Now, suppose here we have 2 services up and running for this configuration. We have, suppose here we have PHP version 5.7 up and running. And same way, we also have the server for, like for example, let's say MySQL, right? And now suppose, let's say if you want to change the configuration here, right? Suppose for some reason, suppose for MySQL again, we want suppose something as suppose 5 version 5.0 as a demo, right? And now suppose we want to update the current version of PHP here. Again, we may have to go back to the container, or we can just simply write a small code that will be reflected into the entire actual implementation here, right? So here, suppose if we want to configure this, if you want to update any of the services, for example, using configuration management, what we did, we simply updated these two. Suppose PHP now has been updated to PHP 7 here, right? Now, because of this update that was pushed to this particular instance here, now this was updated to PHP 8, but again, there has been some compatibility issues with the main system with for PHP 7, right? So in that case, if we have opted for, again, it won't last, it won't be permanent. But again, if we have, that will be also part of the entire architecture here. Right, so suppose I say we want to upgrade this. Suppose I say first after a while here we have done what? We have simply upgraded the entire architecture into PHP 7, right? And now suppose after a while, now suppose they has compatibility issues with PHP 7. So now if we want, we can also automate the task of rolling back as well. Suppose in case of installation failures, this cannot be executed, right? So that's exactly what we can define under the requirement and how it is done as a part of infrastructure followed by the group here. So now let's erase this up and now let's proceed further. So basically when we want to roll back now, whenever we have deployed the update, or we obviously want to roll back to the previous update as well. Because again, suppose once we have rolled out the update, now that update may have crashed the other versions, may not be compatible with all the other software that is already present there, or there may be multiple issues with that particular build that has been updated, right? Now, in case that happens, again, obviously we need a platform so that we can roll back to the previous state. For example, currently we have the PHP version 5.7 up and running, correct? And now suppose after we have updated that to PHP 7, now we can observe some kind of issues with our website, with issues with our web application, right? And if we do not wish to have that kind of problem with our entire server, then we can simply roll back. So that as per the configuration which was up and running, which was completely functional, right? That is exactly what we can do using Ansible as well. And that's why it makes the entire concept, entire process of rolling back as easier as possible. All right. Now, next is we have configuration management tools available. Now, in terms of configuration management tool, here we have multiple tools like we have Terraform, we have Ansible, we have Puppet, we have SaltStack, we have Chef, right? So basically we have multiple tools that that is basically used for the concept of configuration management, where we have discussed the concept of Chef as well, right? So basically Ansible is a configuration management, deployment and orchestration tool. So unlike Chef, which is totally a simple configuration management tool here, but in Ansible, here we have multiple capabilities, not just focused on configuration management, but deployment and orchestration as well. Right, that's why here it is focused mainly on multiple profiles. So if we have multiple profiles here, again, we can simply configure them automatically. We can automate them. We can simply help them in deployment purposes like we have for Docker. And again, here we have the orchestration tool also available here, right? And Ansible is a push-based configuration management tool here, right? So we had discussed this part earlier. So basically we have two types of configuration possible. Here we have push-based and then we have pull-based. In push-based, what happens now? The same, suppose if we want to deploy changes on multiple servers, then we can push them to what exactly the changes is, and then they all have to configure the entire system or nodes, whatever they have, accordingly, right? That's a part of the push-based. Whereas pull-based is, suppose if we have a master, like we have a here, we have master, and those here we also have the same concept of master and slave nodes. All right, and same way for pull, what we have is, suppose if we have multiple nodes being connected here, suppose here we have three nodes that are connected to each other. Suppose here we have node 1, node 2, node 3. Now, first of all, as a part of pull-based configuration, now the system, the master here will simply pull the configuration from its entire slave nodes, right? So whatever the configuration is, so again, this data can be pulled from node to the server, and based on the configuration being set here, right? So depending upon the configuration that's already done, then only we can decide to fill out on basis of that particular requirements. All right, that's the main concept of push and pull. So once the requirement has been met here, then again it will simply push the same into these different containers exactly as on what exactly can be done for these systems. So now let's erase this up. These are the features available in Ansible. First of all, it is really simple, right? Again, obviously it is powerful because again, it has capabilities to model complex ID workflows, right? So when we are focusing with complex ID workflows, then we can simply use it to make sure that we have a better system out there. Again, it is completely agentless, and that's why there is no need of agent or client software to manage the entire nodes here. So first of all, let's discuss on the case study of NASA, how Ansible helped NASA here. Now, NASA needed to move 65 applications from the traditional hardware-based data center to the cloud center environment. That was the requirement of NASA, right? Now, NASA wanted to achieve better agility, so save cost, and more security, because that is a requirement of almost every application out there, right? They need to be more agile, they need to save cost, and they need to provide a better security for it as well, right? And that was the same requirement from NASA as well when they have planned to move 65 applications from on-premise to on-cloud, right? Now, applications were migrated as is to cloud environment. As a result, the environment spanning multiple VPCs and AWS accounts was created, which could not be easily managed because again, if we migrate them as it is, again, they may be deployed into multiple VPCs, right? They may be deployed into multiple AWS accounts. Again, managing multiple accounts, managing multiple VPCs was not that easily done, right? And that's why by managing access rights, again, security patching and other simple tasks could become tedious, right? And when NASA moved into the cloud here, again, they wanted to move the entire team members as well to the cloud platform, right? And what exactly NASA needed? NASA needed a well-defined structure of the content plus the categories they are working in, right? So suppose if we have multiple inventories, now inventories could have been divided into groups and hosts, teams could have been divided into credentials, permissions, and users. And the user, we may have again credentials and permission for those specific users, right? And in project, we can have playbooks, we can have job templates. Playbooks are simply like templates that we had discussed. So here we can create multiple playbooks through which we can start like configuring the entire server, right? So playbook generally looks like this one. So we'll be coming back on this one as well. So this is a simple example for playbook that we will revisit once we move into the module here, right? To understand what exactly it is and how these are structured one by one. All right. Next is now in terms of credential management. Again, here it provides credential management. Here it provides users. Here it provides job assignments and the inventory management as well. All in one tool, all in one solution being offered to NASA in terms of Ansible. All right. Now we do also get an Ansible Tower dashboard as well. Now, just like we had seen earlier, complete dashboard from Kubernetes, right? So having a GUI dashboard is much appreciated, especially by the non-developers team. Suppose someone coming from the non-IT background, non-IT as in non-developers background, or then they really appreciate having a dashboard through which they can visualize the status for the entire system up and running. And then if they want to make some changes, they can also do that easily using the Ansible Red Hat Tower, right? And now suppose if we want to download the Ansible Tower for Linux system, again, we can define this. If you want to know how we can launch it for Amazon EC2, here we have the multiple Amazon machine images that we can simply use here, right? For example, suppose if we want to launch this for any particular region, because here we know we have multiple regions in place here, right? Again, if you want to launch this with a particular image type, here we can simply go ahead and suppose if we want to launch this image here, we can simply define the security group to HTTP because any dashboard needs to be accessed by the browser. And for that purpose, we need to have the HTTP configured, right? So here we can click on review and launch. So what we are doing here, if we want to have the access to the Red Hat Ansible dashboard, then we can simply use this link that we have currently seen, correct? And based on our own setup here, we can choose how exactly we want to use it. We want to download it for our Linux system, or we want to download the Tower for background, or we want to access it in the Amazon EC2, being the system here. Now, because in EC2, we know we can use multiple inbuilt images that we can use to get started on Ansible Tower. And if you want, now here we simply have to choose in which region we have to deploy it, and then we can get started on top of it automatically. All right. So now for accessing this part here, guys, we can simply use this link here called ansible.com/products/tower and then /trial as a part of the entire hands-on here. All right. So now let's get right back. So basically, this is used for getting the summary of all the jobs that has been deployed here, how many hosts we have available as a part of our host count, what exactly the host status is, if it is up, running, or it has been stopped or terminated. We can simply see the entire report as a part of entire Ansible Tower dashboard. All right. As a result, what happened? Updating the entire website for NASA or government went from 1 hour to 5 minutes because of this deployment here. The security patching updates went from multi-day process to 45 minutes because of this configuration management tool offered. Provisioning operating system accounts across entire environment was done within 10 minutes. Application stacks setup time reduced from 1-2 hours to 10 minutes. And again, it achieved a near real-time RAM and disk monitoring service that was again given to NASA by Ansible as a part of the entire monitoring dashboard available, right? And the baseline standards for the AMIs went from 1 hour manual process to becoming seamless, invisible background process by using the Ansible, right? And that's why Ansible improvised the entire efficiency for NASA, right? Now let's go ahead and look at the Ansible architecture here. So basically, Ansible automation engine is being deployed here. So now here we have Ansible automation engine, which consists of multiple modules, APIs, and plugins, right? And these are all connected to the inventories as a part of Playbook, right? So in Playbook, we can define what kind of configuration we can do. Here we have YAML, yet another markup language as a YAML files, right? So if we are working especially with the cloud platforms, and YAML and JSON are the most popular system that we have to be comfortable with, right? So now if we are writing any playbook here, what we can do, we can simply start by running our 3 hyphens here. Now, first of all, here we define the multiple hosts. Like, okay, we are defining the host. This entire playbook is applicable for which particular host here. Then we can define. So here it is available for both, right? And then under variables, here we can define what is the now pass for the account that we are trying to create, right? And then under now, then each and every task here that we need to perform as a part of configuration management, right? Because here we have to define each and every task that we need to perform as a part of configuration management. Now, when we say each and every task, for example, if we are trying to define the entire task, the entire list of all the tasks that we have to perform, what we have to do in a given set, what we have to do is we simply have to define, okay, first of all, what should be done? Suppose here we have step 1, right? So what should be done? Again, we have defined step 1. Again, what kind of configuration has to be run after the first one? Then we have to define the step 2, right? Then step 3, then step 4, then step 5, and so on, right? So these are all sequential steps or sequential tasks that we have to describe in the format of a YAML file. And this entire setup here will be used by Ansible. This is all referred as a playbook. This is all referred as a playbook here, right? So Ansible will simply refer to this playbook in order to execute the system, or in order to start executing the entire statement as a part of the most popular configuration management tool, right? So as you can see here, first of all, here we define the multiple tasks one by one. For example, task, here we define, first of all, install NTP, right? And then we have defined what is a package that needs to be installed, NTP, right? What should be the state, present, and then what kind of notification needs to be done here, run update, right? Then we define, okay, what we have to install next. Then we have to install VIM, right? What is the package that we need to install VIM? We need VIM. Just like we had Docker, we use a command in our system here. Suppose we are trying to install Apache, then we had to use the command as install, and then we had to define the package name, I suppose as Apache 2 or any other package that we are trying to install on top of Ubuntu image here, right? So these all things has to be defined, and for defining those things, we use the playbook here, as we can see here, right? Same way here we define for VIM, again we can define the VIM package, and then if we are done, we can simply start the NTP service. And the services, again, we have to make sure that the services here are up and running. Now, which service here, whether it is started, again, then we have to make sure that if we want to enable it or disable it, we can simply set it to true, or we can set it to false, whatever the requirement is. And that exactly is what the entire playbook is all structured of, right? And that exactly is what we mean by playbook here. And this is the entire architecture that we have seen for Ansible. Now this is what we have seen here. Now playbooks are simply written in YAML code that we have seen already. Now here it is basically used for declaring the configuration and orchestrate manual ordered processes. Now this can be used to launch tasks synchronously or asynchronously. Now basically synchronous is it happens right away without any latency here, and asynchronous is when it happens after a period of time, right? Now it can be executed both synchronous in a synchronous manner or in asynchronous manners as well, in both ways. All right. And this is what we have seen already. Now here, suppose let's say here we have host. Now here we define this for web servers. Then we can define the task. The task name is install Apache 2, right? And then here we can define the app name, suppose as Apache 2 update, cache, yes, state should be latest. And this should be notified. Again, this should be defined as restart Apache 2. And what should be the handlers here? Again, and then we can define the service name as well. That means name should be Apache 2 and state should be restart it. So whatever we need to configure, whatever operations we need to execute, that can be mentioned as a part of Ansible Playbook. Ansible is basically useful for deployment of applications for the purpose of orchestration as well. Ansible is highly useful as a configuration management tool. It's basically used for provisioning and for the purpose of security and compliance as well, as a part of entire use cases for Ansible. And when we are focusing on the orchestration for Ansible, here we can use it to install the LAMP stack servers, deploy HTML and PHP files on web servers, and how we can gather and store data from website into MySQL database servers, right? Then it can deploy the entire servers into the host machines, and the servers can also be managed as a part of orchestration tool service offered by Ansible here. And basically, in terms of provisioning, we can simply provision the multiple Python web applications hosted on Azure for the coding, for testing, and for the deployment purposes. And again, as a configuration management tool here, we can simply make sure, suppose if we want to focus on LAMP stack, right? So again, if the Apache 2 needs to be updated, again, we can use Ansible for simply updating all the services or all the subbeat for Apache 2. Again, if same example that we discussed in the beginning itself, if we want to update MySQL, again, we can do that easily using a LAMP stack here, right? And same way, when we want to deploy any applications, again, we can again work with Jenkins to make sure these are all configured and all done properly on top of deployment, on top of the testing, and as well as on the production server without facing any kind of issues. So that's how we have structured as a part of the entire Ansible tutorial, right? Here we can set it up to our connection. On a data, here we can simply log into our Ubuntu system, and SSH, here we can use the auth to log into our console that we are trying to connect on top of using it with Ansible. Now, in order to start installing Ansible, let's see a short hands-on on how we can get started on installation of the Ansible as well. Now, as a part of our entire hands-on here, first of all, let's see how we can get started on installation of the Ansible here, right? So now let's do one thing. First of all, once we have the connection set up to our remote instance here, first of all, here we have to upload a key file, because again, here we have that part into the system, correct? Now here, first of all, what we need to do is we need to update the Ansible packages here, right? And so that we can add the Ansible repository to our own system. And for doing that, let's do one thing. And again, here we can simply add the entire repository here by using this command here as sudo apt add repository, and then we can simply add the repository back into our Ansible here, right? So here we have to simply enter it. And now this will start, first of all, adding the repository back into our Ansible account here one by one. Now this may take a couple of seconds to be completed. Now once this entire setup is done here, then we can simply use the command as sudo apt get update to update all the existing services out here. We can simply use this command to apt get update to make sure that all the services are updated before we simply start installing it, right? Once we are done with this part here, we can simply install this via the package here, right? So here we have again the simply Ansible package already available to us. So here we can use sudo apt get install Ansible. Now again, each and every packages here will be extracted, and then only it will start updating it one by one. And again, once we are done with this part here, if you want to go ahead and check if this is correctly installed or not, then we can simply use the Ansible and then find the version to just check if this is correctly installed or not. So let this entire process be completed. Now, if you want to just check if we have the current installation of Ansible done or not, so here we can use Ansible version to just simply check if the Ansible has been correctly installed. Here we can simply use Ansible 2.0. Here we can see the correct version of Ansible version here as 2.8.6. All right. First of all, here we have to define the Ansible package, Ansible directory itself, and then we can get started on installing it one by one using the entire package, right? So first of all, here we have to simply add the Ansible repository, and then we can simply update the services and then installing the Ansible package here. All right. All right, guys. So I guess it's almost time now. So let's say we wrap up for today's session here. Kindly show your love, guys, and just hit the like button there. Have a great day ahead, guys. Thank you so much. Take care. Bye-bye.